That must be it. You're my favorite fourth period. All right, so I did. It was recorded. You guys are my favorite fourth period class of the 2018-2019 school year. So we're going to talk first about exponential equations, transitioning from those into logarithmic equations, and then going back and forth. And all of you have done this. All right, so I want you to tell yourself, I've done this. All right, well, in your brain, that's okay. I've done this. All right, so you can do this. All right, you can do this. Aiden, you okay, man? You can do this. There you go. That's what I'm talking about, right? That's support from your classmates. All right, you're not going to get that everywhere, Aiden, okay? You're going to get that everywhere.
I found this all 4 years. Whoa.
All right, so who wants to read that first letter A? Who wants to give it a go? Read that first letter A. It's a very challenging one to start off with. Who wants to give it a go? Not a single person. Excellent. Try it, Manuel. What could go wrong? Try it.
Log subscript 6.
Subscript 6. Bold. Not. It is subscript, but no. We're not going to say subscript. I love where your head's at. There's a word before 6. It's not subscript. Log. Not sub. Not of. Who knows it? Log blank 6.
What's it start with?
A B. Base. What'd you say?
Base.
Yeah, it's base. Very good. So let's go. Log base 6. Okay, Emmanuel?
Log base 6. Log base 6 of square root of 6 equals half.
Yes! Well done. That's a really tough one to start. So how do we write this as an exponential equation? So you went like that. Do you remember what I called that a couple years ago? So 6 to the 1/2 power is the square root of 6. 6 to the 1/2 power is the square root of 6. All right, and I want you to remember that because it's going to come back around on the at your boards problems. Whenever you see an exponent that's 1/2, that means to take the square root. All right, so an exponent of 1/2 means square root. Who wants to read letter B for us? Aiden, thank you so much for volunteering. Letter B, the first one.
Log base 3 times 9.
Not times 9. Log base 3 was right. Log base 3 is something 9. There you go, of 9. Love it. So how am I going to write that one as an exponential equation? 3 squared is 9. Or 3 to the 2nd power is 9. Okay, now we're about to go the other way. Before we do that, I want you to tell yourself a logarithm is just a what? A logarithm is just a what, Sylvester? An exponent. Love it! A logarithm is just an exponent. Somebody's been paying attention. I love it. Okay? So, if this is read as 2 cubed equals 8, how would you write that with a log? Yasmin, what do you got for me?
Log.
Where am I putting that 2? In the, thank you, base 2 of,
8
well, Yasmin is doing it, of 8
equals 3.
Very good. That's exactly right. Now, here's how you check. The logarithm is the exponent. So 3 is the exponent. So the logarithm is the exponent. The logarithm is the exponent. That's how my brain sees that. All right? Let's do the letter B from that one. Peter, if it's 5 squared is 25, what's that with a logarithm? Excellent, Peter. Well done. All right, you can do this. Good job, Peter. All right, let's do part C. Part C, that says, 10 to the -4th power is 1/10,000ths. All right, Brissa, what do you got? So I heard log base 10, and then I heard negative fourth power, but we're going to wait on the negative 4. So log base 10 of there you go, is equal to, very good. All right, now, do you guys remember what happens when you have a log with a base of 10? Do I need to write that? No. What is that called when you have a base 10 logarithm? Sylvester, you had, oh no, Sylvester doesn't know.
No.
What?
I'm trying to like.
Destiny's Child? Is that what?
What?
That's it.
No. What was the question?
The question was, if I see a log and there's no base, so like the log of 100, I know the base is 10. But what's that called when you see a log with a base of 10? It's not, well, this, you're talking about the log of 100? It's not just, it is, like you can think of it as the one. It's the one log that doesn't require a base. It's called the common logarithm. We don't remember common? What'd you say? You're so close. The tip of your tongue.
I was gonna say basic.
Basic is right. I mean, we just, you know.
I guess like the simple.
Exactly. Now, do you guys have, if you have a calculator and you click log, if you click log in your calculator, you'll notice there's no base, so that is a common logarithm. All right? And it shouldn't really be a surprise if you know anything about our number system in America. We use base 10 numbers. Yes, right? The decimals, like when you keep moving it over, like tenths, hundreds, thousands, we're just times 10. Or divided by 10. Yes? Amen. The ancient Egyptians did not use base 10 numbers. Why does everyone not believe me? Every time I say that, I'm like, no way. Google it. GTS. Google that. Some of my stories don't add up, but I'm a math teacher, so they always add up. Now, let's try to evaluate. These, what I tell students to try, is to set it equal to a question mark. All right? Ultimately, these are logarithms, and a logarithm is just an exponent. So if I swoop this, it's going to be 4. So what power gives me 64? So what's the exponent that makes that true? It's 3. 4 cubed is 64. So what is the log base 4 of 64? It's 3. You're looking for the exponent. Ooh, let's try the next one. Log base 3 of 127. So we have 3 to some power gives us 1 over 27. It is negative 3. And let's talk about the math behind that. All right, so you guys learned in probably late middle school or early high school that when you have a base raised to a negative exponent, you put all of that in the denominator, and your exponent becomes positive. So that's why when you see a fraction like this, when you see a fraction in this spot, you know that your answer, your exponent, should be negative. All right? Do you remember the one that Brissa did with us? This one down here? We had a negative exponent, and so this was a fraction. So if you're having trouble with those, what I tell students to do is, okay, 3 to what power gives you 27? 3 to the third power, and then just throw a negative in front to get the fraction. All right, cool beans? Everybody good? Okay, you're going to try these. Now again, once you're done with all 8 of these, you're going to sit down and do the first exit ticket slide. There are 2 exit ticket slides. You're doing the first exit ticket slide. There are 3 questions. Questions? Let's go.